So I'm so glad you all are all here. My name is Emily Schoenfelder. I'm the 4-H Youth Development Educator in Fulton-Mason-Peoria and Tazewell counties. And I'm so thankful that you all decided to join us for our third session of Meet Esteemed Professional. So I am excited to present our engineers for today. We have Ursula Towne and Thuong Lee, both of whom are engineers with Caterpillar and who are members of the Society of Women Engineers for Central Illinois. And they have graciously decided to tell us a little bit about their careers and their career paths, and also do a fun experiment with us.
Hey, hello everybody. I'm Ursula. Hopefully you can hear me okay. Everybody can give me kind of a thumbs up if you guys can hear me. You guys can hear me? I see a few thumbs up. Good. I'm going to keep going. All right, I'm going to take over and share my screen. Okay, so just a little bit about me. Again, my name is Ursula Towne. Here's a picture of me. This is actually at the tech center inside Caterpillar. We actually had a female race driver come and bring her car. And so this was one of the cool experiences I had to have while I was working here at Caterpillar. We actually had a STEM event going on during that. So I got my picture taken with the car. I've got a picture of my dog here. This is my dog. His name is Baldy. He's named after the actual first Olympic mascot, which was a wiener dog. And so he's a little terror, just like he looks. I grew up on a dairy farm in Wild Rose. You can see the picture of a little bit of the driveway here. It looked like this was a picture taken in June in Wisconsin. So we have a lot of snow up there for sure. But I love dogs. I love science. I graduated with a Bachelor of Science in Mechanical Engineering. I did work my way through school playing basketball. This is not me. I wish I could dunk like that, but just so you know. So this is my family. This is my husband, Brett, and he did not take the wiener dog for a ride on the motorcycle, but he likes to think that he could do that at some point in time. So we definitely saved him from that experience. The middle picture here, that's my son, Van, my older son, Van, and this is my younger son, Sam. So a lot of people ask me, especially just because there's so few women in mechanical engineering, why did I choose mechanical engineering? Well, I feel like a lot of it was fate. I grew up at this dairy farm in Wisconsin, and it happened to be a place that was very near an Air Force base. And so we had a lot of planes flying overhead. Here's a picture of an A-10 Warthog. Those were very popular in the 80s. But you know, underlying everything, I really wanted to change the world. That was something about, it's just who I am. It's how I'm put together. And I wanted to fix everything. You see the picture of this old tractor here? This is not from my parents' dairy farm, but it is a very similar picture. My dad had 3 of these tractors on this farm, and you can see it needs a little work, right? So one of the cool things about growing up near this Air Force base is back in the day, there was an effect of breaking the sound barrier that people really don't experience anymore because it was legal to fly over residential areas at top speed. And so hopefully this isn't too loud. I tried to adjust my audio, so just get ready for this. This is kind of like what it was like growing up in the dairy farm in Wisconsin. There it is. So as you can see, that's a battleship. That's not my house or anything where I grew up. But that sound, that breaking the sound barrier, that was something that they did all the time, and it scared the heck out of the cows. We actually would break windows on the barn and things like that if they were low enough and they were going fast enough, and they would break it hard enough. It seemed like it was definitely something that left an impression, let's put it that way. Okay. To tell you a little bit about where I work now, whoops, sorry. So right now I work at Caterpillar. I actually joined Caterpillar in 1995 as a design engineer. I got to design excavator front linkages as well as hydraulics. I've moved around a little bit in my career, but that's where I started. I would love to give the people that aren't maybe familiar with Caterpillar a little bit of a taste of what that is. So I got a YouTube video for us to watch. And so let's go ahead and see if we can get this to work.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
That's one small step for man, one giant leap for mankind. Far horizons beckoning to distant lands.
The low ground pressure D8. selected to pull supply trains across the treacherous Antarctic in Operation Deep Freeze.
We're going to get a brand new system of highways, roads, and streets in this country. A super network of more than 40,000 miles of highways, the magnificent new interstate highway system.
As the sun rises over the mist-laden mountains, we see for the first time the beautiful panorama of the fabulous city of Hollywood, Mecca of the motion picture industry.
Panama Canal, one of the greatest pieces of man-made construction ever known. Good old American shovels. They are working here just past the sheer face of Culebra at the lowest point of the cut, the very real bottom of the Panama Canal.
Ladies and gentlemen, this is Black Canyon, where Nevada and Arizona meet, where the Colorado River once flowed uncontrolled. Here is where man conquered this mighty river to harness its tremendous water and power resources.
It was regarded by many as a bridge that could not be built. The battle was fought vigorously in the courts and in the newspaper columns. But the dreamers and the builders won out.
Industrial miracle of the century. From her workshops for all the needs of modern living. Scientific production of quality backed by immense resources greater than any other in the world. Resources to make possible even greater values for tomorrow.
Okay, so hopefully you guys can hear me again. I thought that was a really interesting video. A couple things I learned. Who knew it was called Hollywood Land once? Like that I thought was very odd. That must be a thing that they decided to go away from. And the cute penguins. I mean, that was just adorable. You can have a video with penguins in it, you're winning that day. So you might wonder what I do now at Caterpillar. So like I said, I started out in excavator, front linkage design. And it's not that I didn't necessarily like that, but I definitely knew it wasn't my niche. I had the opportunity to come down to the tech center while I was working up there, and I got to work on some structures testing down here at the tech center in Mossville. And while I did that, I really figured out that that was actually my love, and so it was always something that I wanted to be able to come back to that. I've actually had the privilege to work as a platform engineer for the last 12 years at the tech center, working on engine development. I started in I6, that's our inline engines, and so that C8.8, that's a size of a bore size, and we go all the way up to C175. Those are our bigger ones. I specialized in C13s, and now I'm working on 3500s. And I wanted to, you can see me there, that's me, and I'm sitting next to one of the things I'm very proud of, which is an oil mist detector, which is something I brought into the lab. That's a little gray box there that's on a side cover. But you might wonder what it looks like in the lab, and I've got a sample. Now this isn't a Caterpillar test lab, but this is a lot like what it looks like. So I'm gonna go ahead and let you guys take a look at this. Let's go back to that for just a second. So, so like I said, it's not a Caterpillar test lab, but it's very similar to how we test engines in our lab. We have lots of different rooms that have an engine in them, and they're running outside of the vehicle or the application that they're in. Sometimes it's a really big ship that the application is. And we try to go ahead and do things in the lab that are a little bit crazy sometimes. You heard as that engine was running that it kind of sounded like it sped up, it was running faster. We do a test called an overspeed test to make sure that the drive line of an engine will satisfy that and be able to handle that. We definitely don't want our engines doing that out in the field for a customer, and so that's why we do them in a lab, and we have basically bomb-proof shelters where we run these engines in, so it's a very safe environment for us to do this testing. And again, the excitement of that was something that kept me interested in this for 12 years. So you could say, fortunately or unfortunately, I got into a position in my career where I had done so much testing and I was so experienced in the lab that they were looking for a 3,500 diesel team lead. And so now my day looks a lot like spreadsheets and pulling out charge numbers and trying to provide the right sort of planning that needs to take place to be able to execute a successful test. So I get involved in a lot of pre-test discussions. We'll talk about what criteria we need to satisfy to make sure we do the right testing in our test cells. Lots of times this is all I get to see of my engines. They come in and they're wrapped from shipping. And so then I get to see them wrapped up, but I don't get to necessarily run them in the lab. But I feel good that I'm at the back door of like helping everybody else be successful for their program. So that's where I'm currently at. In addition to the things that I do in my work, Caterpillar has enabled me to hook up with some really great people in the area. I joined the Society of Women Engineers in 2013. I've had a ton of fun with that group, mostly in the outreach position. We have done so many cool experiments at so many different schools. I mean, you can see a few of them. This is our Charles Lindbergh group here. This is our Dream Center kids. This one over here was at ICC College. This one down here was at Hickory Grove during the launch. This one here was at Bradley University during one of our boot camps. This one here was another shot from Charles Lindbergh. So just a lot of cool, fun experiments that we get to go out and do. I've got a lot of great people, including Thuong, who you'll meet next, who's helped me with some of these things over the years. So in addition to that, I'm responsible for community outreach. So something that is near and dear to especially my division at Caterpillar is the Dream Center. The people that have been running LPSD in my work group have been involved with them, like on the board of that facility for a long time. They're a United Way agency. And so we've been involved with them as far as organizing work projects. So you can see some of the stuff that we do. We go down there and we put in like paneling, we paint walls. Some of the pictures of my team there, like these are people that I work with. They're mechanics and people that I work with at the tech center, and they've helped go down and do some of these construction projects. Most recently, we had a food drive that we were, just because of COVID, so lots of the food pantries and the soup kitchens were closed. And so they were actually taking in food donations from people very remotely, and then that we would hand those out to people as well. So there you see a picture of Peyton, and that's Peyton. That's the hardest he ever worked ever in his whole life. And so that's something to take note of there. But also you see a few pictures of the Project 309 students. That's a science program on Fridays that we do with Society of Women Engineers and the University 4-H Extension Office. They collaborate with us on that. And they have helped bring some really great content. You can see there's Judy Schmidt there from University of 4-H Extension. So that's something we also do.
Ursula,
so what does work look like?
There's a question in the chat box, sorry to interrupt. Asking, what is LPSD?
Oh, thank you. I should probably have to do that. So LPSD, that's Large Power Systems Division. And so that's my group. And so when you look at those engines, they're very big engines. We kind of separate ourselves in terms of size. And so that's what my division is. So good question. I forget that we don't all know these acronyms. Thank you for that.
Thanks.
And so anymore, we have just a ton of remote meetings. We actually recently had a celebration of the 70th anniversary of Society of Women Engineers, and we did it all remotely. This is how a lot of things look. I have been going to work actually since April. Today, because I'm going to do something that's, you know, theoretically quote unquote dangerous. I'm going to be playing with fire here at my house. So I'm not doing that at work. So today I'm working from home. Okay, so this gets me into the next very dicey part of this whole thing. So engines actually work on the principle of the ideal gas law. So you've got a cylinder inside an engine. In fact, we've got multiple cylinders inside engines. And so like a diesel engine, it has a chamber or cylinder in which fuel is added, in our case, diesel fuel, and under high compression, that causes that fuel to ignite. And when that happens, you have a rapid amount of heat and pressure that moves that piston down. And so that's, you know, something that I think that we can actually experience sort of visually, understanding the temperature and how things move based on temperature and pressure with the experiment that I'm going to show you today. So hopefully you'll be a little bit patient with me as I try to switch over. So hopefully you see that we've had an attendant that looks like a plate right here. So this is where we're going to do our experiment at. So I'm going to switch down to this. Okay, so step one, and you might be able to do this at home if you have somebody to help you with the fire part of it. So especially if you're not like an older person, please get someone to help you supervise this. So I have about this much water here. Let's see, I have something, it's about 5 ounces of water. You can see that there. I'm going to pour it on a plate.
Ursula, I'm going to interrupt you one more time. I just
Sure.
wanted to let folks know that Ursula is sharing the screen with the experiment link, but she is also showing us the experiment. So if you switch to your
Can I
gallery,
take that as the main screen somehow? How would I do that?
you'd have to stop sharing.
Would you be able to do that? Do we have to share to that person? Maybe that's what we should do.
No, that's not what I want. Let's see.
You guys can see that okay? Can you guys see that little screen okay? I would rather make this big. So hopefully you can see my little plate there. Something I would like to have somebody pick a color. So I have a really huge batch of these guys. So you can see there's like a whole bunch of food. Wow, how'd you do that? Who did that?
I did that. I'm glad it worked.
Good job. Nice work, Emily. Okay, so we need somebody in the audience to pick a color. I have lots of different colors and hopefully I'll get something close to what you suggest. So is anybody in the chat pick anything?
Red.
Red. I happen to be holding a very red one. So let's see, this says it's actually tangerine. I don't know how red that is. Let's see. Okay. So can you see that okay? I see somebody else said blue.
Yeah, yes, somebody else said blue.
Okay, so we're stirring it up. So it's nice and mixed here on our plate. Okay. And so then the item that I'm going to use to make the heat is going to be this tea light here. We're going to pop that in the middle. And the only matches I could find for some odd reason in my house were my fireplace matches. So they're very long. So you see how long my matches, very long. Okay, so we have this going. We have a really nice big flame on there. So we're going to light our tea light. Okay, and we're going to dump that in some water, which is off here. Okay, so you should see a little candle burning there. Okay, I think that would be okay. Okay, now here's where the magic happens. So I push that on there. We're going to rotate that so you can see the flame a little better. So you guys, what do you think is going to happen? You can start proposing ideas and put them in the chat. So hopefully you saw that properly demonstrated.
That's so cool.
So if you notice, so this is one of these very confusing experiments that if you actually Google this and look it up, people will argue about why it works and what is actually the principle that's working behind it. So a lot of people would say, oh, definitely that candle has used up all the oxygen and that's what's bringing the liquid up inside the jar. That's actually not the case. If you notice that, like as the candle was burning, you should have saw liquid slowly get drawn up in there, right? So it's very important to take note of that as you're watching that experiment. And so the fact that it did it, as soon as the candle went out, what happens is the air that was heated inside that glass cooled. And because it cooled, it condensed, and that condensation, all of a sudden there was lower pressure. All the pressure out here has been the same. And so this normal pressure was sucked up inside the glass. So, and we have, and actually it'll just stay that way, just like that, for as long as I let it sit there. It almost kind of makes a little seal. So.
Good afternoon. My name is Thuong. I'm an electrical engineer working at Caterpillar. So Ursula already kind of gave a quick overview of all the awesome thing that Caterpillar does for the world. So I'll skip through that part. Let me see. All right, a little bit about me. I was born and raised in Saigon, Vietnam, then immigrated to the US when I was 11 years old. I actually went to Mark Bill's Middle School here in Peoria and Richwoods High School as well. I was a mathlete at Mark Bill's Middle School, and then Richwoods High School, I went the college prep program. And then continued here at Bradley University, received my Bachelor of Science in Electrical Engineering degree from Bradley. enjoy arts and craft, cake decorating, traveling, and eating good food, and doing outreach programs with Ursula. So, my family, so there's a picture of me and my family during like a cat open house day at PPG, I think. So these are my two kids who absolutely love, they love machines. So current work, I'm a control system engineer for large wheel loader implement subsystem lead. So essentially I lead a small team to develop software to control the implement subsystem using electrohydraulic components to essentially control these cylinders here, kind of extend and retract the hydraulic flow to raise and lower the bucket or rack and dump, and come up with sophisticated features to prevent structural damage or automated features. And there's different kind of linkage. So this is a wheel loader, this is a wheel dozer, so these are blades, and this is a soil compactor. You can see that the wheels are a little bit different, so it compacts down dirt, and this is for landfill compactor. What does a control system engineer does? So it's basically responsible for designing, developing, and implementing solutions that control the system. So that's controlling the bucket here. So this is one of the biggest machines that I've worked on. So there's a little bit YouTube video that kind of want to show the kids. So this is Caterpillar's biggest wheel loader. Sorry. That looks nice, doesn't it? So it's 240 ton, 994K. That was back in 2016. So bucket's pretty big. 45 tons of material. And just the tire itself is 41 feet high. Actually, the whole thing is 40. So one of the large engine that Ursula works on is probably in this machine, 994K. And the fuel tank is so big that this machine could run for 24 hours straight. And it would cost $3,000, probably up to a little bit cheaper this time because COVID-19 reduced the oil cost, but it costs a little bit less. So that's one of the biggest machines that I'm responsible for controlling just the implement portions of the machine. But there's other groups and engineers that work on the transmission, the engine, designing the linkage, the tire, everything that makes the whole machine itself. This is me actually testing out an automated feature where it's supposed to help like novice operator do a better load of the bucket with full material. So it's called an auto dig feature. I'm going in, not actually using the lever. There's a lever inside the machine. I should have clipped pictures. But driving towards a pile, and the intention is to load up as much material in the bucket as possible without using the lever itself. So this is, I think, a 988, yep, 988K machine. So it's a little bit smaller, actually a lot smaller than the 994K. So that's, we're testing and it actually loading really well, but there's still a lot of tuning to kind of detect when you're actually detecting a pile and so on. So, oops, sorry, next slide. And then some of the specialty applications that I'm responsible for are the block handler for like granite, logger at forestry products, and the scoop machine at wood chip or the coal site, ripper to 854K ripper to rip up dirt. And then I also get to play with remote control machines as well. So we're designing we have a 988K remote control using a console. Eventually we'll move to a station so that you could sit remotely and control your machine like maybe somewhere else in a different part of the world. So that's pretty neat. So typical activity at work on daily, maybe weekly basis. Usually, initially I would capture requirements and work with my team to come up with algorithms and solutions to meet those requirements or controls. On a daily basis, I read electrical wiring diagrams, electrical and hydraulic schematics, and then implement controls algorithm using MATLAB. So there's a link for those of you, maybe like in high school, there's free training material that you could actually learn and teach yourself MATLAB. So a lot of engineers use MATLAB for finite analysis, FMEA, or even coding. So we actually do model-based design and then generate code for us, and then we compile into a flash file software to control the ECU on the ECM to control the bucket. Testing and validating software on test benches or on machines, tuning and getting operator. So here I'm actually at TPG testing different control methods. So some operate prefer lever versus joystick. So we're testing out the joystick controls to control the bucket here. So this is a expert operator that we're getting feedback with. And if you see this little line here, there's actually tools that I use to read in data and analyze data as well. So we're on the machine troubleshooting or kind of reading in data. He's like, oh, it's a little bit like lifting of the bucket was a little bit too harsh, or we have to tune modulation maps and so on. So that's on a pretty much regular basis. I go out on the machine to tune the machine. And then if there's issues that's impacting machine performance, I would go out and troubleshoot issues on the machine as well. And as part of a team lead responsibility, usually like 50–60% of the time I'm getting to do the fun stuff, and the other maybe 40–30% I'm managing budget, schedule, and activities for the rest of the team. And then as an electrical engineer, I thought maybe the kids, I didn't actually do an actual, but I thought this was a good video, just kind of introduce like circuit series and parallel circuits for the kids to try out home.
We're having a little trouble hearing it. If you might be able to either just turn up your computer really loud, or if, yeah,
yes,
if that works.
Is that too loud?
That's perfect.
So like on a daily basis, I use those fluke meter, troubleshoot stuff on the machine or in my test bench as well. So that's just a little of a snippet of the electrical engineering aspect that we learn as well in college, even high school. So how does my job contribute to our world? So the machine that I help build or control, mine minerals such as copper for your cell phone, coal to generate electricity, gold for your calculator, silver for water filtration so that you could get clean water to drink, steel and for your car, copper. I didn't realize copper sulfate is in cat and dog food. Apparently it's in cat and dog food as well, but just lots of minerals that impact our daily lives, as well as materials that you use for, say, for soccer as well. So I kind of want to go over the types of engineers. There's aerospace engineer, biomedical engineering, which like doctors and works with doctors and biologists to develop artificial organs, maybe even come up with the COVID-19 vaccine as well. Civil engineer helps build dams and roads. Chemical engineer works with raw materials and processes to produce, say, lipstick or laundry detergent or even medicine. Computer engineering, I'm kind of in between computer engineering and electrical engineering. So I do software, but I also do the hardware troubleshooting. So work with computing, operating system, and software. Electrical engineering, so essentially takes energy from different motor, like in my case, hydromechanical to move those bucket. Environmental engineers, industrial engineer, materials engineer, and mechanical engineer, and so on. So the list goes on and on. Why is engineering a good career choice? It's full of exciting challenges. You could make solar energy more economical, maybe potentially engineer better medicines and vaccine, provide access to clean water for everyone around the world. We're very fortunate to have clean water here in the US, but there are many other countries outside of the US that do not have clean water. Restore and improve urban infrastructure. So we need those civil engineers and even engineers at Caterpillar to help with the infrastructures as well. Reverse maybe engineering the brain, how it works. Cyberspace, we need those computer science engineers. Advanced personalized learning. The list goes on and on, really. So, and there's a whole bunch of also data analytics and analytics engineer that helps advance health information as well. Two, why is engineering a good career choice? It's broad and diverse. There's something for everyone. So you could go from civil to electrical, like I mentioned, from chemical to biomedical. And if you start out as an engineer, you could actually go into research, product development, which is what I'm doing, design, or manufacturing engineer as well, and quality. And some of them, some of the engineering even goes into sales and technical marketing and management as well. There's lots of different business sectors as well, from software to medicine to healthcare to energy, and designing toys. Someone have to design those Hatchimals that my kids like to play with. And the size of the company could range from 10 employees to even a big company like Caterpillar or a big corporation. So you kind of get to pick what company, what size that you would like to work with. And then why is engineering a good career choice? We actually get paid really well, great starting salaries. So this is from PayScale College Salary Report, but engineers and computer scientists have significantly higher starting salaries than other college graduates. So after 4 years of college, without a master's degree, that's what I actually don't have a master's degree. I only finished with a 4-year degree, Bachelor of Science. And they actually have, for 2019, 11 of the top 15 earning bachelor degrees were engineers. So you could see that petroleum engineers, chemical engineers, computer science, mining engineer, chemical engineer, welding engineer, nuclear, electrical, computer science, and so on. So pays really well. And And why is engineering a good career choice? You work with other talented people. You don't work by yourself. It's actually a requirement that you be able to collaborate, work well in a team environment. So engineering is a team effort. There's always diverse ideas that you could bounce off of each other. Like, hey, have you think of this way? And then someone else like, hey, have you think of it in this way? And you kind of improve on was already there before. So many people come from different fields, and like I'm an electrical, I collab with mechanical engineers or data scientists to get information that I need on a daily basis. And good collaboration skills and communication skill are very valued. Anything else? So these are some of the websites that I have that might be useful for parents and kids to kind of try out. Any questions for me?
That was amazing. While folks are kind of thinking and processing, I would love to know from both you and Ursula, like what do you think that young people who are interested in becoming engineers, what can they be doing right now in order to help them along their career path?
Sign up for SweNext.
Perfect.
That's a good idea, Tom. That's really a good one. So the other thing I think that is really important for engineers is just be really curious. Like if you see something that's happening in your physical environment and you want to understand why, you know, the internet is full of so many answers. Some of those answers are incorrect, but try to learn as you go. Try to take math and science in school if it's possible. If it's There's lots of kits like those links that Thuong put up there. Those are some really good links to be able to look into, and you'll be able to learn a lot.
Yeah.
That's great advice. Thank you. What other questions do you all have? We had a lot of great comments in the chat box as we were going. So Ursula and Thuong, I don't know if you were able to see them, but people were commenting on how cool the videos were. I know that we have a member from I think Ohio, Sui, who is joining us and says, thanks for sharing your engineering adventure. So that's awesome. What else? Any other questions, thoughts, comments?
And you don't have to be good at math or science to be an engineer. You just have to have a curious mind and try to critical thinking, I would say.
Yeah, and there's so many different focuses of engineering once you get into it. There's some engineers that they get into it and then they focus on marketing, for instance, which have really good interpersonal skills and communication skills. So it's, you have to have a good mix, I think, of different areas that you can focus on.
Yeah.
Thank you.
I do want to share one more thing, Emily. It's the parting gift that we're going to give everybody. Do you have the presentation? You could bring up the last slide. So that's a local company. Actually, they're out of Pekin. They were making these kits, I think, to give out during COVID because people weren't having this opportunity to do things hands-on. And that's, of course, something that we like to encourage. The more you do that, the more you're exploring your world, I think. And so all the people that signed up for this, if you wish to, if you provide your address, we will go ahead and send you one of these kits for free. You can not only make a house for a bird, you can actually, learn some hands-on woodworking skills. Don't worry, there's instructions, so you don't have to just figure it out on your own.
We had one other question in the chat box. How would I schedule a school visit for my elementary school students after COVID?
That's a great question. So if you go to our website, you could contact us either through that or through the outreach email. Both of those can be found on the Society of Women Engineers website. That is on the slide pack that will go around to everybody. Type in Central Illinois Society of Women Engineers. I think you'll probably find it very easily in a Google search. But yeah, a contact area on there. You can just write us an email and let us know what school you are, when you're thinking. Hopefully that is not too far in the future.
So Caterpillar does do a IG STEM, like an annual event, IG STEM, introduce a girl to STEM, like every October. So they do. The selection process varies from school to school, but that's an opportunity too for middle school girls to sign up as well, or like say, hey, talk to your science teacher, like I'm interested in attending it. This year we'll most likely will be going virtual, of course, but so, yeah.
That is fabulous. And I am so excited about the birdhouse kits. It is amazing that you all in SUI have allowed us to do that. Oh, who donated those? Did you say someone from Pekin was the question?
So we're working with a place in Pekin that they were making some to donate. These are actually purchased through the Society of Women Engineers here in Central Illinois. And so we're working with them to get those to people. So it's actually our group that's doing that.
That's awesome. Thank you.
No problem.
Fabulous. So a huge thank you to you both. I know that I learned a lot and I'm so excited. So thank you all. We have a thumbs up as well. So thank you all for doing that. We, again, will follow up with all of the links, and we still have registration open for anyone who is interested in meeting a STEAM professional we have 2 more weeks. So you can join us for those exciting opportunities as well. And we thank you all for joining us, and I look forward to seeing you next week. Thanks all.
Yep. Bye, Emily. Thanks,
Bye.
everybody.
Thank you.